Okay, so today we have this question, which is a very easy question, which is we have to find this uh, greatest common divisor of the array GCD. So basically, the thing is that what is a GCD? The answer itself is from the question, it is GCD, right? So if we will write like greatest common divisor. So if we are having two numbers, let's say we are having uh 20 and uh 42. Okay. So we have to find, we also call this GCD as HCF, highest common factor. It factor is itself a division, right? Whatever divides the number, so completely divides the number. So what are the factors or the divisors of 20? It is 2, right? Like we will not consider one. One is itself a divisor. So if we will consider one, then at least like everything is there. So 2, 4, 5, not 6, not 7, not 8, not 9, 10, and 20 itself, right? And what are the what are the divisors for or the factors for 42? It's 2, it's 4. Is it 4? No, 4 is not the divisor, right? So 2, let's write the common divisors. Okay, so 2, 3, 6, 7, and 8, not 9, 10, 11, 12, no, 13. 13 will be, not 13. No, 13 will not be the GCD. Okay, so 13 is not 14, uh, and 21 and 42. These are the common factors. If we will consider one as well, मतलब कुछ नहीं होगा, then one will be there, right? Now these are the factors of 20, and these are the factors of 42. Now we have found the divisors. Now we have to find the common divisors. What are the common divisors? 1, 2, uh, nothing else. Only 1 and 2. And now we have found the common divisors. Now we have to find the greatest of them. So it is 2. So the answer is 2. So this is the way we find it. This is the simplest way we could find the greatest common divisor, right? Now, what is the Euclid's algorithm and how is it making it easy to find this particular thing? Let me raise this. Now, what does this Euclid algorithm says? What does this Euclid's algorithm says? अब इसको हम समझते हैं. What does it says? So it says कि if you are having like let's say two numbers, let's say I have two numbers a and a comma b, right? If I have a comma b and I want to find the GCD or HCF for the a comma b, and the condition here is a is greater than b, then what we are going to do? Then the HCF will be the GCD will be GCD is equals to the uh, the one, like will do the recursion for this until b is no b is equal to not equal to 0. We'll do this until, right? तब तक हम इसे करते रहेंगे जब तक हम b is equals 0 पर नहीं पहुंच जाते. तो अब हम क्या करेंगे? What we will do, the GCD for a comma b will be GCD of b comma a modulus b, right? और जब तक ये नहीं पहुंच जाता, let's say now this b part becomes 0, then this a is going to be the GCD for that particular numbers, right? तो अब क्या है? Let me give you an example. How is this happening? How is this possible? Okay, let me do this. Okay. So the thing is that we have a number, like let's take the number those only 20, 42. We want to find the GCD, and the condition was that A should be greater than B. So we will be finding the GCD for 42, 20. We have just swapped the number, nothing else. It is not going to affect the GCD. Common divisors will stay the same. So now GCD of 42, it should be GCD of 20, 42 mod 20. So 42 mod 20 is what? It will become GCD of mod. Mod means that what is the remainder? So it will stay 2, right? It is going to stay 2. Now, now this is the B part and this is the A part. Now is B equal to 2? No, 0, sorry. Is it equal to 0? No, it's not equal to 0. So we are going to continue the process until we get B is equals to 0. Now this GCD is going to call another GCD of 2. B will come here and A mod B, which is 20 mod 2, which is 0 actually. So it is GCD of 2, 0. So now P is equals to 0 and the A which we are left with is 2, and this is the answer. This is the answer of, or we can say this 2 is equals to the GCD, or the greatest common factor. Now this reduce the steps, number of steps, and we have some other things as well. Like now we can take a bigger example, and it is going to reduce the uh, things which we have. Like for example, we have a bigger number, a larger one. Like we have we want to find the GCD for 100 and 720. Now, to find the to find the division, to find, like if we will follow the traditional steps, then what happens? We have to find the divisors of 100 and the divisors of 720, which is actually a great number of divisors, right? And it is also going to cause a multiple steps, a lot of work to find the answer. Now, and if we will follow this Euclid's algorithm, it will say that GCD of, it will first consider 720, 100, because we want A to be the greatest number. If you want to you want to perform in a vice versa way, it can also happen, but we're considering this A to be greater and B to be the lesser one. So now B will come here, comma, this 720 mod 100. And this is actually going to be the, this is actually going to be the 20 only. This is going to be 20. 720 mod 100 will be 20 itself. Now this GCD is going, is it, now this is the B part. Is it equals to 0? No, it's not equal to 0. So we're going to call another GCD, which is this B will come here, becomes A, and 100 mod 20. And now it will become GCD of 20, 0. Now if we will consider this as again one more steps, then it will be 0, 20%, or 20 modulus 0. Can we divide any number with 0? No, it's not possible. So that's why we are ending the process here, right? So this is of not any use. Now we found actually the answer, which is A, when we got B is equals to 0, which is 20. So the highest common factor or greatest common divisor is 20. So we can see that we find the answer, or we found the GCD within 2 steps only. So that is the beauty of this Euclid's algorithm. And now we will see the intuition behind this, which is very pretty thing, which I wanted to actually explain. Okay, let's say, like talking about two numbers, which I'm taking is um, any two numbers which don't seems to be the common having any common factor easily, right? So, for example, we have 12 and 32, which is actually this is a very common example when which everyone does take. So now what is happening is I am taking A as 32. So now I am taking A as 32 and I'm representing that 32 as a bigger block, right? This is the 32. The whole is 32, right? This whole thing is 32. And we have B as 12. This is obviously the smaller part, right? B as 12. Now I want to see that what are the common factors. Now we will think that this B is going to, now obviously the greatest common factor is going to be the smaller of these only, है ना? मतलब it is going to be lesser than or equal to the smaller between these two, between these A and B. उनसे छोटा ही होगा. मतलब the smaller, like common factor could never exceed the smaller number between these A and B, right? ये तो we are sure. So now we are going to check that is this 12 or is this the smaller number is the common factor between, then we will try to divide this the larger number with the smaller number. Are we getting what we got? We got actually 2 in return, and we are still remain with the remainder, which is 8, right? So it means that this is definitely this smaller number is definitely not the greatest common factor, right? So this is not the common factor. So what we are going to do, let me erase this. This is not the common factor. Okay. So if this is not the common factor, then but we know that this A, like this B is accompanying, or it is actually accustoming these two B's, and we are remaining with a remainder called 8, right? So now we know that these, if these, there will be this A, which is 32, is accompanied by two B's, which is 12 and 12, and one remainder, which is 8. So now, if we will find any factor for 12, then it is actually going to be the factor for this part of the 32 as well. But we are not sure about this part. This part. Okay, this part of the A. Now, if we will find the common factor between this 12 and the 8, then it will be happening for both the A and B, because 32 का ये वाला जो पार्ट है वो 12 ही कवर कर रहा है, 12 twice कवर कर रहा है. तो if we will find any factor for 12, then it will be the factor for this part of the 32 for sure. And और इसके लिए हम find कर ही रहे हैं. So what we are going to do, that हमने 12, अब instead of finding the common factor between 12 and 32, what we are doing, we are finding now the larger number which we are left with, 12, जो छोटा था हमने उसको आगे ले आए, and the remainder. So that is what was the remainder, 32% 12. So this was 8. So now we are finding the GCD for 12 and 8, right? Okay. Now we're finding the GCD for 12 and 8. Now moving ahead. Okay. So we are finding the GCD for 12 and 8. Now the thing is that we want, okay, so now the A is 12 and P is 8. Okay. Now, we know that now this is the smaller number. 8 is the smaller number. Does 8 divides 12 completely? No, it divides but by 1, and still remainder remains, which is 4. Now we know that if we this 8 is accompanying or accustoming this 12 by this part, and we are still left with 4. So we know that now if we will be finding GCD for 8, comma 12 modulus 8, which is actually 4, then it is going to actually break the problem. Now I am remembering a quote which was, if you have a larger or a difficult problem, then replace that larger problem with a smaller or easier problem which has the same answer. So this is the concept behind this Euclid's algorithm. So now what we are left with? We are left with the, actually let me take this off so that for the good place. Okay, now we are left with GCD of 8, comma 4. Now A is 8 and B is equals to 4, right? Now we want to find that does this 4 divides this 8 completely? Yes, it does. Yes, it does divides. Then we are left with nothing remained. So we don't have to find any GCD for the remaining part. So it means that this 4 is going to be the common factor and the greatest common factor between this 12 and 42. So this was the intuition behind this Euclid's algorithm, and it's a very pretty thing to understand. So I hope I was able to make you understand the thing, and we'll be covering more topics, interesting topics, and multiple intuitions behind multiple algorithms in upcoming videos. Thank you.